Okay, here we go. So our first one is 6 3/4 plus -2 1/2. Now, a very, very good habit to get into when you do these are called mixed numbers. 6 3/4 plus -2 1/2. They are mixed numbers, and the best thing to do when you're dealing with mixed numbers is to change them into improper fractions. Most students do completely fine on the 6 3/4. They do completely fine. They do 4 times 6 is 24. They do, and then they add 3 to it. So they get 27/4. Students typically don't have any trouble going from that mixed number to that improper fraction. It's the -2 1/2 that really, really confuses students. You need to think of this as -2 1/2. Think about it this way. That negative belongs to all of it. You could think about it as -2 plus 1/2. And then what would you do with that negative sign? Well, if I was going to separate it even more, what would I do with the negative? Does it belong to the 2 and the 1/2? Yes, you would distribute it. So it would be -2 and -1/2. All of it is negative. So what I encourage students to do is to completely ignore that negative and change 2 1/2 into an improper fraction. So 2 times 2 is 4, plus 1 is 5. Then make it negative. So then I have plus 5/2. Okay? Now, once you get to that point, then we need a common denominator. My common denominator is 4, so I'm going to have 27/4. Okay? 2 goes into 4 2 times. So when I do 2 times 2, I get 4. That means I've got to do the top times the same thing. So -5 times 2 is -10. Okay? At this point, we're in good shape. 27 plus -10 is 17, and we keep our denominator. Okay, can I move to number 2? Okay, number 2. It has 2/3 inside parentheses minus 1/5 minus 1/2 minus 7/10. Okay, now order of operations tells us that we have to do what's inside parentheses first. A very, very common thing that I get from students is they look at that minus and they think that they need to distribute that to the 1/2 and the -7/10. That's not a crazy thing to do, but it's not necessary. And the reason that it's not necessary is because I can simplify 1/2 minus 7/10. You have to distribute when there's a variable involved. So if I had -1/2 x plus 3, I would have to distribute that because the 1/2 x cannot be combined with the 3. Okay? But because I can combine 1/2 minus 7/10, I don't need to distribute. So I am going to focus on this first. And so I'm going to look at my 3 and my 5. So I need a common denominator between my 3 and my 5. And you absolutely do not want to turn these into decimals because 2/3 gives you a repeating decimal. And you don't want to do that. You've got to be comfortable working with fractions. My common denominator between 3 and 5 is 15. Okay, I'm going to keep my minus sign. How many times does 3 go into 15? 5 times. What's 5 times 2? 10. Okay, so what I did there is I multiply the 3 times 5 to get my common denominator. If I multiply the bottom by that, I also have to multiply the top. Okay? How many times does 5 go into 15? 3. So I'm going to multiply my top times 3 here. Okay? So my common denominators my common denominator is 15. My equivalent fractions are 10 over 15 minus 3 over 15. Okay? 10 over 15 minus 3 over 15 is 7 over 15. Okay? Now, I am going to deal with, and this all happened inside parentheses, what's my common denominator between 1/2 minus 7 over 10? 10. Okay? So, how many times does 2 go into 10? 5. 5 times 1 is 5. I can leave my 7 over 10 exactly as 7 over 10 because it's already in terms of 10. I already have a denominator of 10. Okay? I'm still dealing with what's inside the parentheses. 5 over 10 minus 7 over 10 is what? Negative 2 over 10. Some students have lost that negative sign. Okay? So if you made a mistake there, it could have been that you lost that negative sign. Okay? Now, what happens to that minus and negative? It becomes a plus. I had several students say, I don't know where you got plus from, Alicia. Why is it plus? Why isn't it subtraction? The reason that it turns into addition is because we have that double negative right there. That's why. Okay? So I've got 7 over 15 plus 2 over 10. I actually had a couple students stop right there, and I think they just weren't thinking about going further. But I can go further. I don't have a variable. So I can keep going. What's my common denominator between these two? 30. So I did have a student say, oh, well, I've got to do a common denominator of 150. That seems really high. 150 is a common denominator between these two, but it's huge. Okay? And you get it by just saying 15 times 10. Okay? But it's not the one you want to use because the numbers are just so huge. What you can do if you're not sure what the common denominator is, take this larger denominator and start doing multiples. Multiples are you just kind of keep adding that number to it. So what's the next multiple after 15? 15 plus 15. 30 plus another 15. 45. Then another 15. Yeah, people are like, I'm not going that high, Alicia. 60. And then we got 75. So if you start with that, eventually you're going to be like, hey, 10 goes into that. Okay? So my common denominator is 30. 15 goes into 30 twice. 2 times 7 is 14. Okay? 10 goes into 30 3 times. 3 times 2 is 6. Okay? Are we done? No, we're not done. What goes into both of those? So my final answer here is 2/3. Okay? Can I go to the next one? Number 3. Number 3 and 4 deal with a lot of exponents. So I have 3 times negative 4 squared plus 5 times negative 2 to the third. I didn't have a ton of questions about number 3, so that makes me very hopeful that we did okay with that. The order of operations says that I have to do grouping symbols first. This does not have any grouping symbols in it. If you look inside the parentheses, I have standalone numbers. I have negative 4 inside the parentheses. I have negative 2 inside the parentheses. I can't simplify anything inside there. So my first step of order of operations, I don't have anything that I need to do. My second step of order of operations is exponents. So I'm going to deal with negative 4 squared. Negative 4 squared means negative 4 times negative 4. Okay? What's negative 4 times negative 4? Positive 16. And you don't have to say the positive. I just want to reiterate that it is positive. Okay? That is what I have to do first. So I get 3 times 16. After I've simplified negative 4 squared, that's where I get the 16. Now, negative 2 to the third, what that means is negative 2 times negative 2 times negative 2. What does that give me? Negative 8. Okay, so now I've got 5 times negative 8. Now, 3 times 16 is 48. Please don't get mad at me. I'm not insulting your intelligence. I'm just making sure you know how to do that. If you don't see immediately that 16 times 3 is 48, this is how you would do it. You would do 16 times 3. 3 times 6 is 18. 3 times 1 is 3 plus 1 is 4. Okay? So that's how you get 48. 5 times negative 8 is negative 40. Okay? So my final answer here is 8. And I think you guys did super well on this one because I didn't have a lot of people say, ooh, I got stuck. But I did have a lot of people come and talk to me about number 4. So I think people did get stuck on number 4. So let's look at number 4. And I think it's just got lots more steps, and that's why. So number 4 is 2 to the third plus 3 times negative 1 to the third. Then that's still being multiplied there. And I think that confused some people. Okay, and then I've got negative 1 and 2. Okay. I don't have any grouping symbols. Everything that's inside my parentheses is individual. There's nothing inside my parentheses that I can simplify. Now, do you see that negative 5 and that negative 1? There may be, you don't want to deal with that yet until after I've dealt with all the exponents. If that negative 1 was raised to the second power or the fourth power, that would have turned it into a positive 1 after that. And so you don't want to get ahead of yourself. So you don't ever combine those until after you finish the exponent stage. You've got to deal with your exponents before you deal with those double negatives. So I'm going to deal with negative 1 to the third power, and I forgot one. I need to deal with this 2 to the third. I'm going to deal with negative 2 squared, and I've got a positive 2 squared. So I'm going to deal with those first. Okay? 2 to the third, that means 2 times 2 times 2. That's going to give me 8. 2 times 2 times 2. It's not 2 plus 2 plus 2 is 6. A lot of students will do 2 times 3 and get 6. But that is an exponent. That means we are raising it to that power. So it's 2 times itself 3 times. 2 times 2 times 2. Okay? Negative 1 times negative 1 times negative 1. What is that? Negative 1. Okay? Then I've got negative 2 squared. What is that? It's positive 4. Good. Okay. Now, I'm still not going to deal with this negative 5 and negative 1 because I've got to deal with that 2 squared first. What's 2 squared? 4. Okay? Now, I'm going to deal with this, which is my multiplication and division step, and this right here. If at this point you want to deal with it that way, you're in good shape. Okay? if you want to do, like if you want to change the -5 to plus a negative, now it's safe to do that at this point. Okay? So I'm going to keep my 8 because that's addition. 3 times -1 times +4. -12. Okay, then I've got -5 times -1 times +4. 20. Good. So, now I do addition and subtraction. 8 plus -12 is -4. -4 plus 20 is 16. Is it locked? Yeah. Sorry about that. Okay. So that was probably one of, I would say that's the second hardest one on here. I think that one's kind of tough. Okay. Number 5. Did you ever think you would be so excited to see variables when you got to number 5? Right? So now we have 5x minus 1 plus 7x plus 4. And the directions to this say to simplify. Okay? Now we have to distribute. The reason that we have to distribute is because x minus 1, we can't combine those. We can't combine x minus 1. So we have to distribute that 5. So I end up with 5x minus 5. You've got to distribute it to both. Then I end up with 7x plus 28. Okay? 5x and 7x are like terms. -5, positive 28 are like terms. So this one I end up with 12x plus 23. Not too bad. Now, number 6 says -3a squared plus 7b squared plus 9a squared minus 2b squared. Okay? Yes, question? No, I gotcha. This one I threw in there to remind you that like terms is the same variable raised to the same exponent. So the fact that I've got a squared and b squared, I can combine my a squareds and I can combine my b squareds. Now, if I had something like this, if I had -3a plus 4a squared, can that be combined? Can a and a squared be combined? They can't. Okay? But we can combine these. So I've got -3a squared and positive 9a squared. So that gives me 6a squared. Then I have 7b squared minus 2b squared. And I have 5b squared. Okay? Now, I want us to pay special attention to how we do number 7. Because how we do number 7, we're then going to piggyback off number 7 to do number 8. Because I do think number 8 is the hardest one because we make it the hardest. So, number 7, the directions to number 7 said simplify. So I've got 3 times 2x minus 5 minus 4 times 5x minus 2. Okay, and I am simplifying. That means I combine any like terms that I have. The first thing that I've got to do is I've got to distribute. Most students do completely fine on the first one for distributing. They do 3 times 2x is 6x. 3 times -5 is minus 15. The second part, we are distributing a negative and we are distributing a 4. So, we have negative 4 times 5x. That gives us negative 20x. Then we have negative 4 times negative 2. What is that? Positive 8. Okay? So don't forget that you've got to distribute that to both. Okay? So now I have 6x and negative 20x. That gives me negative 14x. Negative 15 and positive 8 is minus 7. Now, number 8 says evaluate. And what happens with number 8 is you are given a value for x. And our first indication when we get that is we just want to put the negative 1/2 everywhere there's an x. And that's a reasonable thing to do. It's not a wrong thing to do. It's very reasonable. However, it also makes it very difficult. Okay, and we're evaluating, x is negative 1/2. I didn't write down what that is. Can you confirm that it's negative 1/2? Yes, okay. So what students do is they immediately take that negative 1/2 and they plug it anywhere that they see an x. And that's fine. It's not wrong to do that. But there are so many negative signs in there that students aren't sure why something's negative and why something's positive. If you will simplify this first, it makes it significantly easier. Okay, so I'm going to distribute my negative 3. So I have negative 3x minus 3. That negative is going to both. Then I have plus negative 4x. So I have taken a 4 and I have multiplied it times a negative x. That gives me minus 4x. Then I have positive 4 times negative 2. That gives me minus 8. What's negative 3 times negative x? Positive 3x. Then I have negative 3 times negative 4. Positive 12. Now I've got negative 3x here, negative 4x, and positive 3x. Now, what I would do is I would see that and I would be like, ooh, look at that. Negative 3x and positive 3x just cancel out. So what am I left with as far as x's are concerned? Negative 4x. Now, if you didn't notice what I did, like if you were like, if your brain doesn't immediately see those opposite numbers, and you said, okay, negative 3x plus negative 4x is negative 7x, then you added the positive 3x, are you going to get negative 4x? You are. You're going to get it the same way. Okay, so you can go ahead and add those up. Now I've got negative 3, negative 8, and positive 12. So negative 3 and negative 8 gives me negative 11. What's negative 11 plus positive 12? 1. And look at that. Instead of having 3 x's, some of them being negatives, how many x's do I have to plug in? 1. And it makes it significantly easier. So now I'm going to put that negative 1/2 in. So I have negative 4 times negative 1/2 plus 1. Okay? Negative 4 times negative 1 is positive 4. So my answer here is 3. If you did this the long way, if you plugged negative 1/2 into all those x's at the beginning and you got 3, you need to give yourself a huge pat on the back, because that is not easy. Okay? Okay. Number 9, after you get through number 8, you're golden. Number 9 is 4x squared minus y squared. My x value is 2. My y value is -2. Okay? I can't simplify any of this. I can't combine it at all. So I'm going to go ahead and plug in my values. Sorry about that. It's y equals -2. So I'm going to have 4, 2 to the second power. Do you see how I wrote that? You do have to be a little bit careful with that. Minus -2 to the second power. If you made a mistake on this one, it would have been with that double negative. We see that double negative and we immediately want to make it plus. Correct? We immediately want to make it plus. You can't do that until after we deal with the exponent. Okay? Because really what that is that's a -1 times whatever's in that parentheses. So it really falls under the multiplication stage. So when you see double negatives like this, don't deal with it until you've dealt with the exponents. Okay? What is -2 squared? What's -2 squared? +4. So that makes all the difference right there. So I've got 4, and then I've got +4 here, because +2 squared is also 4, minus 4. Once I deal with that -2 squared, I no longer have a double negative that I need to deal with. Okay? So now I have 16 minus 4, which is 12. If you had trouble with this one, it was probably because you dealt with that double negative too soon. Okay? Can I go off of this? Is it okay for me to go? Okay, I don't have the words in front of me. I want to say 4 less.
Someone took a picture of it.
Oh, good. 4 less than 1/2 a number?
Yeah.
Okay. Okay. For less than, this term right here, less than, that's an indication that that 4 is going to come second. So if I say, my daughter is 4 less than 10, that's how old my daughter is. I know it's a weird way to tell you how old my daughter is. Okay? But if I say to you, what is 4 less than 10? 6. Okay? So if we were to write that, we would write 10 minus 6. When you see less than, that is a red flag that says, I'm going to put that second. Okay, so I want you to look at 4 less than. And what that means is minus 4. 4 less than means minus 4. What does 1/2 mean? 1/2, yep. I heard it as soon as I said it. Okay, and what does a number mean? Good, and you can really put any number in here that you want. Okay, I usually do n just because we're talking about a number. 1/2 a number is represented as 1/2 n, and that's 1/2 times n. Now, if you wrote this -4 plus 1/2 n, there's nothing mathematically incorrect about that. Okay? In general, you're going to see it as 1/2 n minus 4. This is the correct answer based on the words. 4 minus 1/2 n is incorrect. Okay? If students make a mistake, they write it like this. 4 minus 1/2 n. Okay? That less than. Now, sometimes you'll see some that say more than. And technically, the more than means you're supposed to put it second also. But that doesn't matter nearly as much because addition order doesn't matter. So it's not wrong if you do the order incorrectly when you're doing addition. When you do the order incorrectly when you're doing subtraction, it's wrong. The value's incorrect. Okay, because 10 minus 6 is very different than 6 minus 10. Okay? Okay. Does someone have number 11, the words? Okay. Can you tell me what it is?
10 times the difference of a number and 6.
Thank you very much. 10 times the difference
Of a number and 6.
Perfect. Okay, 10 times the difference of a number and 6. Hopefully we know 10 times. What does times mean? What operation? Multiplication. Okay? So I know that I'm going to be doing 10 times something. The difference means what operation? Good. The difference of a number and 6. So that means n minus 6. Where students mess up is they don't put the n minus 6 in parentheses. And it's just practice. It really is. You just kind of have to keep practicing these. So 10 times the difference of a number and 6 means that we've got to multiply 10 times this quantity of n minus 6. So if you've got the difference of, or you've got the sum of, or the quantity of, those are all kind of red flags that you're going to put something in parentheses. Okay? Okay, yes?
What made you put the negative in minus 6?
The difference. So the word difference is the answer to a subtraction problem. If I had said sum, what would that mean? Addition. Difference is the word for subtraction. Quotient is another one that students don't remember. What is quotient? Division. We always remember product and sum. What's product? Multiplication. Sum is addition. We forget about difference and we forget about quotient. Excellent question. Thank you for bringing that up. The last one is about some guy's birthday, right? Barry, is that his name? Brian. Brian is n years old. Is that right?
Yes. How will he be in 20 years?
Good. Brian is n years old. How old will he be in 20 years? Now, and again, students look at this and they're like, I'm supposed to be solving something. You're not solving anything. You're not solving anything. He is n years old today. He's n years old today. And we're looking at how old will he be in 20 years. Now, if you wrote this as 20 minus n, that doesn't change the value because we're talking about addition. So n plus 20 and 20 plus n, your answer is the same. But if you get in the habit of writing it in the correct order, then you're going to be very safe when you have subtraction. Okay? That is what I had planned.